Hey everyone, so today we're going to talk about the different medications that we use in the treatment of heart failure. We're also going to talk about some of the biopathways that help us regulate blood pressure and other factors that are at play in heart failure. So we're really going to have a clear understanding of what pathways are important to the symptoms surrounding heart failure and what medications we can use to control those mechanisms to help alleviate the symptoms. So first, let's recall that during heart failure, the heart is just not working as well as it could be working. It's running inefficiently because of some problem somewhere in the heart. So what are we going to do? The idea is we want to medicate the patient in a way that's going to lessen the burden that we place on the heart. So how do we lessen the burden that we place on the heart? Well, we can talk about ways to lessen the burden from an upstream perspective. So recall that upstream from the heart, we have blood returning to the heart. So one way to lessen the burden is to decrease the amount of blood that's returning to the heart. So I'm going to talk about the amount of blood returning to the heart as workload. I just think it makes a little bit more sense in terms of being able to discuss this with some sort of clarity. But we also often talk about the workload that we put onto the heart as preload. Now, preload has a pretty exact definition. The preload is the pressure exerted on the walls of the heart by the blood prior to a contraction. But we can talk about workload and preload for this video in the sense of the amount of blood returning to the heart. So we want to decrease our workload. We want to decrease the amount of blood that's coming into our broken pump. So downstream from the heart, what we can do is decrease the pressure that the heart is having to pump against. So I just want to quickly define pressure as force over area. Okay, so to help illustrate this point, imagine that you're playing with a pump water gun and you pump it 5 or 6 times and then it starts becoming difficult to pump the water gun. Why is that? Well, it's because we've developed high pressure in the water gun, and that pressure is exerting resistance on the work that we're doing with the pump. So we're going to have to work harder in order to pump against that high pressure. Well, similarly, in the heart, if we have high pressure in the aorta and the arterioles and the arteries downstream from the pump, from the ventricle, that ventricle is going to have to work harder to get blood out into the body. So what we want to do is decrease the pressure that's downstream from the ventricle so that we can make it easier for the ventricle to pump out into the body. A word that's often used to describe the force against which the ventricle has to pump is called afterload. Okay, so we want to decrease afterload and we want to decrease preload. Now I just want to say quickly that a lot of the medications we're going to be talking about are going to change the area of the blood vessels, right, which is going to change the pressure in some way. If we increase the area, the pressure will go down. So we're going to see how this works. Similarly, when we talk about force, we're talking about blood in the vessels exerting a force on the walls of the vessels. So the more blood you have, the more force you have, and vice versa. The less blood you have, the less force is being exerted on the walls of the vessels. So you'll see how all of this works in a moment. Alright, so before we start talking about individual medications, I need to introduce you to, or refresh your memory of, the system in the body that controls blood pressure. Right? And this system is effectively going to control the amount of burden that we place on the heart. So this system is known as the RAA system, which stands for the Renin-Angiotensin-Aldosterone System. Okay, so we're going to go through this system quickly and we're going to discuss how it works, and then we're going to talk about medications that work on this system. So to begin, we start with a molecule called Angiotensinogen. This is an inactive molecule that the liver produces that's floating in the bloodstream. So it's not doing anything, it has to be activated. And it's going to be activated by a molecule called renin. So renin is produced by the kidneys when the kidneys sense that blood pressure is low. Now remember, during heart failure, we're not giving out enough oxygen-rich blood to the body, and that includes the kidneys. So the kidneys are going to interpret that lack of blood as low blood pressure, so they're going to produce renin. Okay, so what renin is going to do is renin is going to convert angiotensinogen to angiotensin 1. Okay, so angiotensin 1 doesn't really do anything on its own. Okay, it's a step to the production of angiotensin 2. And in order to convert angiotensin 1 to angiotensin 2, we need the help of what's called ACE, which is an angiotensin converting enzyme. Okay, so this enzyme is found in the lungs, among other places, but primarily in the lungs. So we get the conversion to angiotensin 2. Now, angiotensin 2 is no slouch. Okay, this is a really powerful molecule that's going to promote vasoconstriction. Okay, so this is the big factor in how high our blood pressure is and what kind of burden we're placing on the heart. Because vasoconstriction is going to decrease the area of the blood vessel, which means it's going to raise pressure. So when angiotensin 2 binds to the smooth muscle in the arteries and causes vasoconstriction, it's going to increase pressure by decreasing this area. Okay, so we're going to use various medications to control the amount of vasoconstriction, which is going to help us with the symptoms of heart failure. So angiotensin 2 goes on further to the kidneys, to the adrenal glands, and produces aldosterone, or rather it encourages the production of aldosterone, which itself also promotes vasoconstriction. So again, it decreases the area of the blood vessels, which raises pressure. But aldosterone has another effect, which is fluid retention. Okay, and when we retain fluid in the circulatory system, we are effectively increasing the force on the vessels of the circulatory system. Because remember, the fluid is going to exert a force on those vessels. So if we retain fluids, we're going to increase the pressure in the circulatory system. So the medications that we're going to use to lessen the burden of the heart are going to decrease vasoconstriction, which means that this area goes up, which means that pressure goes down. If we control fluid retention, then we decrease the force that's working on the vessels, which means we're going to decrease pressure, but we're also going to decrease the amount of blood that's returning to the heart that the heart's going to have to pump out later.